How we seen in the little trailer on top of this topic, we will speak about the race split system. We will start by a little reminder. What we need is a system who can split by split group drivers of same level by sorting registered drivers by iRating from bigger to lower. Then we will group them. Aliens with big rating will fill the split 1. Intermediate splits will be filled by drivers less and less good rated, and on very last splits we will find the beginners of iRacing. Now let's go on a less easy case when things are multi-class events. The system still creates as many splits as we need, and top splits we need to are cutted in several classes fields. So here on this example, split 1 and 2 add a green area for GT and a blue area for prototypes. For the following splits, we know we don't have any prototypes to be multi-class, so in that case, split 3 and 4 will be mono-class on the main populated category, so here in green for GT drivers. Okay, and now we have the framework. We will sort the drivers like previously, but class per class. So we'll start by the GTs until all the drivers have a slot in a split. Now we change category to work on prototype, and we will spread them starting from split 1. In that example, because there is less prototype drivers than GT drivers, we can get splits like the split 2 on this example, which mixing very last drivers of prototype class, so the slowest one and often the less safe too, with very skilled GT drivers. These kind of splits are favorable to race accidents and can be very frustrating from each side of the problem. We know these GT drivers doesn't want beginners with them, which can damage a car or be sometimes surprisingly slow in the slowest parts of the track. And from the beginner's side, maybe they will prefer experience a race with other beginners in GT, which can be less pressure for everyone. For this presentation, we will be focused on Le Petit Le Mans 2018, which is the last special event we experienced on iRacing. To do that, we will use the GitHub link shared on this topic. It will allow you, if you want to try, to download a zip file containing the project. This project contains all the source code written for this benchmark, and if you just want to use it, go in bin and debug folder to find the exe file. So this is how it looks. In the source tab, we will load data from Petit Le Mans. There is several CSV files which come with this project, so we'll pick Petit Le Mans and we will hit the load button to have here the entry list. The only difference with reality is I don't know the data of which driver registered the car or which driver joined the car later. That's why in all results I will show you, there can be tiny difference with reality, around several percent only, but this difference is known and will be considered along all the presentation, so it doesn't have any influence about the purpose. Now we will open the matching tab, and in the algorithm list we will pick the classic, very close to iRacing. It will run mostly the same process than iRacing one, because we first need to understand. So here we can see 14 split has been created in 3 categories: the Corvette C7, the Daytona prototype, then the GT3 of the GTD category, and then the GTE or GTLM class. We can also see from split 1 to split 5 we had the 3 classes. After that we don't have any remaining C7, so we move to a 2 classes system, and after that there is no more remaining GT3, so we move to a single class split system for GTE. So we are familiar to that, because this is what we experience on each special event from a while now on iRacing. And some problems occurs, like on the split 5 for example. Here are prototype drivers which have around 1400 of iRacing are mixed with a lot more skilled drivers in GTE with around 4,000 iRating. This difference is highlighted by this column, which tells us the difference between softs, between the DP soft and the GTLM soft, is around 61%, and it is quite a lot. We can also see another unexpected effect. If we look at the global soft, so it's the soft mixing all the car of this split, it starts by being descending as we want. So it starts from 5.7K to 5.1 to 3.3 to 2.8 to 2.3, and then it bumps to 2.7 and start decreasing 2.4, 2.2, 2.1, and another bump here to 2.4, etc. So it's also a sign telling us in multi-class mode we don't really have what we expect. If we speak now about the average of all these classes differences for all the splits, we have the data here in the bottom, and we can see an average difference of 49% between classes, and we will try to find ideas to work on that point. If we'll continue to understand how it works to have this result on iRacing today, we have to know, because the field size is set on this event to 45, that data is set by iRacing. Because that, iRacing tried to cut in 3 equal parts, because 3 classes, and that's why we have a 15, 15, 15 cars repartition. And then iRacing filled the list by iRating descending. There is also little difference, little improvement. We can see them here, for example. All these DP splits have 14 cars instead of 15, and here is the same, we have 19 cars instead of 22. This is the result of little improvement to try to balance car number on each split. We can try to disable that with the algorithm row classic, just here to see and understand. And here we can see iRacing want to avoid this situation, which is having 15 cars, 15 cars, 15 cars, 15 cars, and then not enough, so we have only 11 now. Same thing here to avoid 22, 22, 22, and then only 13. So to avoid that, iRacing try to round the classes, and I try to reproduce something close, because it's a good idea we have to keep. Okay, the first question we can ask ourselves is about class distribution. In the case, like the Petit Le Mans, where driver registration were very unequal between classes. As you can see in the pie chart, we had only 11% of Daytona prototype for 60% of GTE, for example. So knowing that, we can ask ourselves, is it a good idea to try to equalize these classes in each splits? I have no personal opinion on the question before trying things. So we'll try to implement another algorithm, which basically try to make proportional classes field to exactly match the entry list. So in each split we will have 11% of Daytona prototype, 66% of GTE, etc., etc. So if we run this algorithm, and if we look only at the soft differences, we can see things are really better now, but other things becomes really bad now. About the field size in Daytona prototype, to have only 5 Corvettes in each split is really uninteresting for everyone, I suppose, and we will clearly understand why this is not a possible solution. So maybe this approach is a little too extreme. We try to balance it a little with an improved algorithm. This one will try to continue making proportional classes, but we will add a constraint into it, and we can play a little bit with it. That rule says smallest categories, so DP here, cannot be with a field size less than 37% of the biggest class, so here's the GTE. If we run it, we now have a list which looks like more than today's list. We can see we have now a little bit few C7. Previously we had 14, now we are about 12, 13. Things appear to be a little bit diluted and a very little bit better. I will put side to side the two algorithms. It will be easy to compare. Okay, so if we look differences between iRacing system with egalitarian class policy and a system more proportional, things are a bit improved on normal splits. We came here for 40% to 30, here 50 to 40, but we'll still experience the same issue where splits containing the lastest items of a class. Again, we have too much difference, I think. 1.5k for C7 here versus 3k for GTE. It's not a lot better. If we try to play with this parameter, we can see more things are diluted and better is the difference between classes, of course, but on the other side, the number of cars in less populated category is worst. So it seems very logic. Okay, we will forget that for a moment and try to imagine something different. Imagine now we have an iRating floor. Less than it, we will group beginner's driver, and more than that for skilled driver. So we will use the classic iRacing matchmaking algorithm, but on the two parts of the list instead of one list, and after a separated computing, we will put them together. It means the less rated driver we'll put here in red on this slide, which are on our example around 1.9k iRating, will comes field bottom splits, and for everyone else, the normal list, if we can see that, we will fill normal splits like ever before. We will try this experiment using the double list algorithm with a parameter to 1.9k iRating, and let's see. Okay, on top splits we had very few difference than before. The only differences comes with more diluted C7. Few C7 are now gone. We have around 2 C7 less by split because prototypes of split 5 disappeared. It's because their rating wasn't big enough to be in this first part of the list. We have to look below to find them when other categories are around the 1.9k2. So I have to say it's not a very conventional list to have 3 classes, 2 classes, 1 classes, like ever before, but after that to go back to a new list in fact, so we turn up to 3 classes again, etc, etc. But at the end, this solution seems to be not so bad. We have very less of differences than before. And in the case of iRacing wants absolutely to keep equal classes in each split, I think it looks like a possible solution. If we compare then the 39% of average difference between classes on every split, now we are only about 29%, so it's nearly the half, which is not so bad. And more important than that, we don't have now splits having big differences like 60% before, with the lastest remaining C7, and also same thing with lastest GTD. This kind of transition is now more smooth, and if we still have differences, we have very less this problem. Okay, we've seen previously 2 approach, full of IDs each one, and the main thread is now why not trying to combine that together. And to do that, we will use the algorithm, double list, and car class distribution. So with that combination, we will first cut the lists with the 1.9k iRating system. And for each part of the list, we will use a more proportional car class distribution. So if we run it, this is what we get. Average class distribution is not very good because we only have 20% of differences between classes. And we see every big problems are now gone. Here, for example, there is 2.1k versus 2.7k drivers, so it's good matching. This split is 3.3 versus 2.5 versus 2.2k. I think it's driver which can share the track together without big problems. And for beginners, I think the situation is more suitable to them too. We can also see the global SOF of every split is now more consistent, without bumps like before. Everything is descending now. If we try to go a bit further in this concept, we can try to keep this bottom list of less than 1.9k drivers, but for the main list, we can try to resplit it in two on its median point to have in fact 3 lists now, less than 1.9k, the first half and the second half. We can try that on the triple list algorithm. Here too, we have good results. If we look at the global difference average, we have now only 14. On the other hand, we had to accept this distribution a little bit strange, where we will find DP in split 1 and 2, because their SOF is close to the best. After that, no more C7, and we will find them again in this intermediate list. To be clear, mathematically it's a bit better, but is it a distribution we want or not? It's an open question. So let's go back to the double list algorithm, which seems to me more simple. What I will suggest you now is to try it on other events to see if this combination of solution can be good on other races we experienced recently on iRacing. So we will start by Les 24 Heures du Mans of 2018. We will load the data on both windows. So the classic algorithm close to iRacing is making that. Here we have a little better situation than the Petit Le Mans because classes distribution is a bit better in the entry list. We have 34% of difference, but we have some splits like this one with issues where 1.3 LMP2 are mixed with 2.7k GTE, big difference. And same problem here with LMP1 of 1.3k versus GTE of 2.3. If we compute the same list with our new algorithm, we decrease now the global difference to 9% only. A good point is we don't have very less LMP1 at the point. We only reduce them from 18 to 13, so the race is still interesting for them. It's an important point. And the other benefit is we now have a multi-class experience for almost all the splits from 1 to 11 instead of only 7 before. So I think this solution has more benefit than problems. If we quickly try the triple list method, you will see differences are not very low because there is less inequality between classes than in the Petit Le Mans. So we will keep on the double list system, which is almost really good. Let's try the next year of Les 24 Heures du Mans, 2019. This is what the iRacing matchmaking is expected to do and what we experienced. So HPD disappear around split 10, and this split has a lot of differences. 1.3k here versus 2.6, quite a lot again. And even if we look upper than that, we have several splits with 1.6, 1.8 SOF here, so really low SOF, which are mixed to really skilled GTEs. If we go to 11 or 12, we only have 2 categories, and it's the same story again with P1 around 1.4 or 1.1, which are mixed to GTEs more than 2000. If we'll play it on new algorithm, you can see the average difference go from 31% to only 10%. There is no more splits containing big problems. Just maybe a bit in the very last ones, so problems go back to the right place. Same benefit, we have more splits with a multi-class racing experience, and I also think it's something we want to target more realism in this kind of event. And the number of cars in each class is not too bad. We came from 18 P1 to 15 or 14, maybe 13 sometimes. So yes, it's a bit less, but if traffic is better, I think it's maybe not so bad. And I personally think it's not shocking, because if you compare that to reality, to real 24 hours of Le Mans, you can see there is also very few P1 versus GTE, for example. So I think it seems good. We will try again on another special event, and we will choose the 24 hours of Daytona. This is how it looks like. Problems mostly come between split 10 and 13. Classes with SOF less than 1.6k are mixed with GT than more than 2.5. And if we quickly compare it to the new algorithm, this is what we get. We see everything is green here because everything is below 15%. The average difference was 37%, and now we are speaking about 10%, which is pretty good. Okay, so this is how it looks like on big special events. I'm pretty sure in this case there is good ideas to take from that. Of course, there are still many things to try. Why not playing these parameters, for example? Before finishing this video, I want to show you on an IMSA sprint race. I have chosen a random IMSA race which were pretty popular. It was one of the races just before the Petit Le Mans in IMSA, so that's why there were 5 splits. We will quickly try this algorithm on that, just to open our mind on sprint race or smaller events. So this is the list with the current system, when there is very few C7. In top split we have all the C7, 5 drivers have more than 2k, plus 2 beginners, which are mixed to the traffic with a GTE SOF more than 5k. If we play again with our algorithm, this is what we get. At this point we only have 6 C7 for the top split with a SOF around 2.9k, so it's something okay for a top split, I think. Then we will find the 2 remaining C7 on the top split of split 345, which are bottom splits designed for our beginners below our iRacing floor of 1.9k. We can also see the global difference comes from 39% to 17%, so it's globally a lot better. So I think in a case like that, with around 4 or 5 splits, we can maybe start to apply our solutions. Of course, these solutions are not final solutions. I think it's just good ideas we have to continue working on. I really hope this work of analysis will help everyone to understand the problems. Between us first, of course, but also for iRacing staff. For most brave people, you are free to play with the project on the GitHub. Gives me feedback in this thread if you find something new interesting. If major change comes, why not making a part 2 or an update of this topic and video? And for iRacing staff, I will be happy to talk with them too if needed, or to try helping them better if I can too. Thanks a lot for watching.